Hi everyone. We're just going to get started now as soon as everyone's kind of ready. I'd just like to thank Mike for coming along today for his talk on the journey from monolith to microservices. I'd just also like to thank Gehard for hosting the event tonight and for Nearform for sponsoring the event as well. And apologies for the Rihanna concert as well.
If you want to go to the Rihanna concert, I won't be upset.
If there is any Rihanna fans out there, we are extremely sorry about that.
How long before we start to hear her? Come on.
There's some seats down front. Alright. I'll make sure I stay behind the tables. That's not to hurt anybody. Cool. Well, thank you all for having me. It's the first time I've ever presented in Dublin, in Ireland at all, so this is pretty exciting. My name is Mike Gehard. I work for a company called Pivotal. We have an office here in Dublin. How many people have heard of Pivotal? Are we hiring, Tyson?
We are hiring.
We are hiring, so if you're looking for a job, talk to Tyson or Brian or some of the gentlemen and ladies in the back. Hopefully this talk will incent you like, wow, those guys are doing cool things. I should go join that team. So we'll get started. Any questions before we get started? That's good. I would also like to keep this somewhat interactive, so if you have questions during the talk, please do stop me. I'd rather deal with them in somewhat real time than wait till the end, because I'll have forgotten what I said anyway, so we'll get started. So a little bit about me. One of the big parts of what we're doing now at Pivotal is helping clients move big ol' legacy, gigantic financial services, you name it, gigantic Java apps onto Cloud Foundry. So how many people have heard of Cloud Foundry? Oh good, sweet. How many people have heard of Heroku? So think of Cloud Foundry as like Heroku, except you can run it on your own servers. So platform as a service, very easy self-service developer thing, which is revolutionary to some enterprise developers. Some of these folks are used to waiting 6 months, 8 months to get servers. So that's part of what I do. The other part of what I do is we have a team called Spring Cloud Services. How many people are Java developers in the room? How many people write Spring? Okay, sweet. So we have a team, Spring Cloud Services, that writes cloud technology for Spring. So if you're familiar with any of the Netflix open source, what we've done is we've taken all the Netflix open source, wrapped it in a nice little Spring Boot wrapper, and then given it back to the community. So that's the other part of my job. And this is a big part of my job, is to not be a chief principal, senior consultant scientist. So what you find a lot of days in microservices is a lot of people that want to tell you how cool microservices are with a lot of theory, but don't really tell you the pain and suffering that comes with going to microservices. So one of my goals here is to tell you, yes, there is pain and suffering. Yes, there is a benefit to going to microservices, but you don't have to go all the way. There are steps along the way that we can take with these big monolithic applications. This is all going to be in Java Spring, so I apologize for people that aren't Java Spring people. How we get to that point, and give you little stopping points along the way. So a lot of people will tell you, you either get a monolith or you get microservices. There is a point, there is a path in the middle that isn't all or nothing. So how many people actually are working on a monolith that needs migrating? Yeah, super fun, yeah? How long does it take to deploy that thing?
6 hours?
Yeah, 6 hours. Like, that's a lot. 24 hours. Holy cow, I think you win. Something. But they're probably making the business a lot of money, so these apps are running. No, okay, well that's unfortunate.
Free.
Oh, interesting. So a lot of people have things that they want to migrate. How many people are actually actively migrating that monolith? Cool, so the same people that have one are actually migrating it, which is cool. How many people wish they were migrating their monolith? But aren't you migrating the monolith? No. Yeah, okay. How many people are actually building microservices right now? Okay, so let me guess, you work at Kilt? Okay. pretty good guess. He's the one that brought out the microphone, so that was actually an educated guess. How's it going?
Very good.
Yeah. Gil tends to have one of the better approaches to microservices from the little research I've done on the group.
Probably, yes.
Yeah.
For me, that when I joined Guild, I worked for a monolith company, and then like everything is really good.
Yeah.
It is a smooth, you know.
Yeah. And that's one of the big bummers, and one of the reasons I love to give this talk is we hear about these success stories. We hear about Netflix, you hear about Spotify, you hear about SoundCloud, you hear about Guild, how cool their microservices architecture is. What we fail to find out sometimes is the pain and suffering that those engineers that started out in the monolith, when it was a monolith at all of those organizations, many of them Rails monoliths. Any Rails developers in the house? Okay, I'm gonna bash on Rails for a little bit. I'm an ex-Rails developer, but we don't hear about like the pain and suffering and how they got to that point. So part of this talk is also to try to understand that in a general way. Being a consultant, I need to come up with generalities, but each one of those organizations has come along that path in a different way. And that's all specific to that organization. So we'll see how this goes. So I'm going to start out, give you a little background. I'm going to kind of outline this path, which hopefully will sound logical. This path is an experiment. So this is not, I'm not telling you this is the only way to do this. So if I get halfway through this and you want to raise your hand and tell me I'm crazy, that's totally fine, because I'd love to have a conversation with you. My goal is to get this out into the community and then continually refine the process so we can all iterate towards the power that Guild has and the power that Netflix has and the power that other people have. And then show you the path. So this idea, while not revolutionary or new, started with this guy named Mike Baranek. He was our office director in Boulder at Pivotal. Has been writing Java for way too long. Worked for a company called Gnip, which was then acquired by Twitter, working on systems that consume Twitter firehose data. And he came with this idea of an application continuum. So, as I said, you don't get either a monolith or microservices. What this idea proposes is, depending on the age of your application and how much you know about your domain, you can start anywhere from here all the way to here. So how many Rails developers have written Sinatra applications? Yeah, so unstructured. Like, here's Sinatra, here's one file, away we go. And then you end up rebuilding 3/4 of Rails by the time you're 6 months into a project. Yeah, see? So that's unstructured, literally. Flat directory structure, no, maybe one file, but when you're small, who cares? If you've got 1,000 lines of code, do you really need 12 directories in all of this organization? Maybe not. And if you fail at that point, you haven't done a bunch of work. And what this thing says is you can move along this continuum. And this is the path that this migration is patterned after. And you just move up and down this thing. So and this blog post is really good if you want to read more about this. There's another guy that I have found lately named Simon Brown. Has anybody heard of Simon Brown? He lives on some really small island near Britain. I forget what the name of the island is. But lo and behold, Simon says, I can write a well-structured monolith, which looks a lot like a series of microservices without the box. And he gives a couple of talks. He has a book that I found very enlightening in a very pragmatic way. Not a lot of theory, just like, let's get stuff done and let's move down this path. And it's called Modular Monoliths. I highly recommend taking a look at this. So that's where this talk comes from. That's the inspiration for the talk. The actual nuts and bolts of this talk came out of a client project, because what better way to test a theory that you have is to use it on a client project. So we were working with a large customer in Colorado, in Boulder where I live. Large entertainment company, think Netflix competitor type thing. Had big monolith, Rails stack, written by a bunch of outside consultants, making the company money, successful. Making money, handling traffic. They then decided that it was not going to scale for the future. They saw the writing on the wall. They're like, we know this is going to not scale, so we need to get ahead of this. So they came to us, we gave them some ideas, and the rest of this talk was based on this project. So this is the project is now, I think, being worked on in one of our offices. I'm not sure if they've signed the contracts or not. So I've tried to get as real life as possible. This is not something I sat around and like drank 4 beers and was like, whoa, this might be a good idea. Like people see, like CTOs that were like, oh yeah, this might be a good idea. We should invest some money in this. So their goals were to take a monolith in production, making money to a more sustainable solution. So outside of our friend who has the 24-hour deployable monolith that is not making any money because it's free, anybody else who's migrating to monolith probably has this problem. So app running in production, doing stuff. They knew that it wasn't scalable for the future. It was a Rails stack. It was pretty horribly put together, but it was working. I tend to value running software over really well-architected software for a little while. They wanted to get multiple teams involved. So they knew going long-term they were going to have a problem where they needed to get multiple people and multiple teams involved. So one of their goals was to make space enough in a sandbox for everybody. And they wanted to add resources without overcrowding. So they wanted to be able to scale resources up and down without them bumping into each other. So these were the goals for the project. If your goals match up with this, awesome. If they don't, your mileage may vary on how this works. So I like to remind people that ideas come from a set of constraints, and if your constraints don't match this, then I can't guarantee that that's all going to work out. But I think it will. That's my hypothesis. So current state, a bunch of API servers, multiple clients, JavaScript, set-top boxes, so Xbox, cable boxes, things like that. This one was interesting. So some dead code. A measure that no one could tell us exactly what it was, but it was greater than 10% and less than 100%. That was fun. You're like, great, what is this? What can we cut out? We don't know. So that made it really interesting. And it lacked comprehensive API tests. So very little testing at the client level, such that if we made a change, chances were we were going to break something and not figure it out till a little bit too late. So that was kind of scary. So not super excited about that. Everybody know Kent Beck? If you don't know Kent Beck, I highly recommend reading his book, 2 books, XP Explained and TDD by Example. I tend to quote Kent a lot, and this is one of my favorite quotes. Going back to the your mileage may vary thing, a lot of this depends. So if you want to play a drinking game, drink for every time I say it depends in this talk. You might want to get more beer. And this is one of my favorite quotes. I have 2 engineering degrees. I have a chemical engineering degree and a master's in software engineering. I firmly believe that engineering is saying depends just enough times and then answering the question. So if you ask me a hard question and I don't give you an answer, I'm going to probably tell you it depends, and then I'm going to ask for more information. So which comes first? So I am of the strong belief that we start with a monolith to microservices. You go on the internet, you ask 6 people, you will get 7 answers as to how that should go down. So Martin Fowler believes monolith first. There are many other people that believe you can do microservices first. I like to start with well-structured monoliths because I don't trust myself to do a good enough job early on in a project to get the domain, the bounded contexts right. And this is the key. So how many people are old enough to remember service-oriented architecture? Like enterprise service buses, yeah, all that fun stuff. What we're doing now is no different than an SOA, with one exception. We are talking about bounded contexts. This is the one change, is we are talking about microservices as running software that encapsulate bounded contexts. If you remember enterprise service buses, where did all the logic live? In the bus, which is what went wrong. This is the key. And this is the driving force on whether or not I go to microservices. So that continuum says, the more I know about my domain, and what those boxes looks like, the closer I can get to microservices. If I know nothing about my domain and I'm a startup and I build microservices first, I'm going to get them wrong. I am. That's just what happens. And that cost is really expensive. So this is why I believe this, because I don't trust myself to get those right. So the path, the nuts and bolts. Safety first. So at Pivotal, we tend to test drive everything. So the first thing we wanted to do was avoid this. You go into these big code bases with no tests that are running in production, and the analogy we like to use is you have an airplane that's flying. You have some options. You can land said airplane, get everybody off, put them on the new one, and take off the new airplane. That's the Big Bang rewrite. We all know, anybody that's read the mythical Man Month, any of the books, we know that tends to not work. You have another option, which is you have plane flying, you pull plane up next to it, you start to move people across in midair. If you choose that one, I highly recommend a safety net because you don't want people falling off it. So the first thing we wanted to do was build some API level tests. Why did we start with API tests and not other levels of tests?
So you don't break the clients that are currently using it.
So our goal was to keep the clients happy because we knew the guts were going to change. We already knew that the system was not in a shape it needed to be, so unit tests were useless to us because we were just going to scrap them all anyway. Because it's in production and making money. So we had to, when we pushed a release of the software, we wanted to make sure it was working.
But these are the steps from monolith to microservices.
Yes.
And you start with testing APIs.
I start with testing the external API using this picture. So if I have a monolith and I have a JavaScript client, I have an API. That thing might be 20 controller endpoints, 100 controller endpoints. But I have a monolith. I have one big box with all my clients. Where I want to go is that. What I want is the same API, maybe with some new ones, that the clients still hit. To the clients, nothing has changed. They're still hitting endpoints, but those are now free-running processes. In order to go this direction, I have to make sure that when I extract code from monolith, run over here, I haven't broken anything. So that's why we started with the API tests. Farthest out, least feedback, but the only feedback we wanted was yes or no, was it broken or not. We didn't care about internal design at this point. That wasn't our concern.
How would you test APIs?
Excuse me?
How would you test APIs?
So if you're a Rubyist, capybara, literally JSON in, JSON out. Treat it like a black box. Because I don't know if those database tables are going to change. I want the big black box testing.
So you're testing the contract.
I'm testing the contract. Exactly. I'm testing the contract. Yes, sir.
But how did you test the behavior? As in, okay, you can test the contract that says this is the input and this the output. But when you go to a real system, you're going to be testing maybe thousands of inputs and outputs at the same time. Not normally test.
Oh, so like performance testing.
Well, performance testing, parallel testing.
That was the least of our concerns at this point. I just wanted to know, when I push code, did the JavaScript break or did it not break? Very, very, very important. Not our concern at this point. So why not write your test that way? So I'm just going to write the tests and do that. So we actually contract testing. Everybody's seen Pact? Written by ThoughtWorks. It's consumer-driven contract testing. So in a series of microservices, I have producers and I have consumers. What I want to do is say that when one consumer or many consumers expect something out of my microservices, the producer gives them that back. JSON in, JSON out. The cool thing about Pact is it's all specified in JSON, so that I have a JSON document that can be published between producers and consumer teams. Knowing that as long as everybody agrees to that's the contract, we're good to go. Pact will also generate stubs on both sides. So if I'm a consumer, I can take that JSON, I can feed it to a Ruby client or a JavaScript client, JavaScript library. It will generate a free-running JavaScript server that I can hammer. It will also generate a Java backend such that when that generated client hits the Java backend, it will run those tests. So all automated, you can share it. A little bit hard to set up, but kind of the best that we could find. So when we had those in place, our goal was to make sure we didn't break anything. And again, we didn't care about design. We just wanted to know yes or no, so it was something broken. So that was our first goal. This can sometimes be the hardest thing that you will do, because we said we had dead code. We probably had dead endpoints. Did everybody know what it was supposed to do? So how do you know what's broken and what's not broken? So retrofitting tests, anybody that's tried to retrofit tests knows that that's a touchy situation to get into, because how do you know the tests are actually good? But we were pretty successful, and we had our safety net in place. So, step number 2. For you Rails developers, this will be revolutionary. I've been told you can do it in Rails, but DHH would crucify me if he saw this slide. You want to see your domain in the root level of your hierarchy. So if I look at this is a Rails app. Not to bash on Rails, I could do this just the same in Spring. This is not just a Rails problem, but we were always told, let's divide our application up into layers. Those layers are views, models, and controllers. Looking at this directory, what can you tell me? If you didn't have these open, what could you tell me about this application, what the domain was?
Rails.
It's Rails. You could tell me that it was a Rails application. If you look at this one, ignoring the lovely Java directory hierarchy because of packages, what would you tell me this thing did?
Web stuff.
Web stuff. It also dealt with orders and users pretty easily. So, let's do this. In this situation, if I asked you to change order functionality, what is the maximum number of files you may have to touch to make that change? 3. In that situation, what is the maximum number of directories? Well, sorry, I shouldn't have said files. Maximum of directories you have to change is 3. In this case, how many directories would you have to change? 1. So if I'm dealing with orders, most likely my order stuff is in here somewhere. So I'm now moving in a direction of high structure. And as I said before, the secret to microservices is bounded contexts. Why is this the first step in moving to microservices? What is this?
Context.
That's a bounded context. I have another bounded context here. I start to give myself room. So, as Uncle Bob says, you should always see your application domain. Does anybody know Uncle Bob Martin? You've seen his talk on architecture of the lost years? This is his idea. So I wanted to minimize the number of directories that I have to touch. Why is it less costly to evolve bounded contexts here? So if I'm full microservices and I need to evolve a bounded context by moving functionality, what do I have to do? I have to move either files or logic, possibly across repositories, if you're a person that uses one repository for every application. Here, I can futz with those boundaries very cheaply by simply moving the files around in Git. And if I've got 3 developers or 2 developers, I don't need 4 directories or 4 repos. I'm also delaying architecture decisions. So anybody who's read Martin Fowler's post on delaying architecture decisions as long, it's either him or Uncle Bob, I forget which one. I want to delay architecture decisions as long as I can. So what I've done here is I've delayed that architecture decision. I've delayed deploying more applications. And your application could sit here for quite some time, I postulate. Nobody's proven me wrong on this yet. So, and you can just sit here and iterate on the domain, add functionality, especially if you're a startup. You can just do this. Okay. So now I've spent 6 months, a year of development time here. I've got 12 bounded contexts or 6 bounded contexts. The next thing I want to do is break out into components. So I want to give myself more space. Now that I have 6 of them, I might have hired 12 developers. It's getting a little tight in that code base, simply because people are bumping into each other. I also want to begin to solidify dependencies and boundaries, because I want to lock those APIs in place at some point. Once my bounded contexts are set, I want to lock them in place. So let's see what this looks like. Oh, look at that. Okay, so what this looks like in Spring, if you're not a Spring developer, hopefully it'll make sense. So here's my Java directory. I have my application. This is a jar file that is built by Gradle. I have two files. I have an application, which is my Spring application that boots the whole world, and I have my controller. That's it. Those are my applications. I then have made the choice down here in the components directory to break out components. So again, along the lines of I should be able to see my domain in the top, as high up in the file structure as possible. I have an application. I know it deals with subscriptions, but really it's just a web app. Here's where all my business logic sits. I've created very solid boundaries, so I can't cheat as much anymore. Because these are separate jar files and they are built, what do I prevent from this structure in Java? What is the bane of your existence when you're trying to break things apart? A circular dependency. Your user model, why do the user model always end up as the God object in every application? Because everything depends on it and it depends on everything else. So here, I disallow circular dependencies because the jar files will not build if there is a circular dependency. Because this jar can't be built if it depends on that one and that one can't be built. So by solidifying those boundaries, I now create harder lines in the sand where I can't cheat as much. Simon Brown takes an interesting approach with these components where he says the only public API that these components have are the API that is consumed by the application. He even says, I don't even know what a repository is of these components. They exist, but it's an implementation detail. So he even goes as far as saying, I build microservices in process. And this gives me the ability to start moving that direction. So what I have here, one of these is, so you'll notice here, this is a little pattern I've been using. So in Java, I create method objects. These are use cases. This is my public API for my system. In my payments API, I can charge a user and it takes a payment gateway. So these might be the only thing you interact with as a client of that thing. And then I see what this is. It looks like a microservice. It's an endpoint. I do the same thing for all the email ones. So here, send email, payments have the same deal. Here, because I'm doing payments, I can now swap out my payment provider and I can wire that all together in Spring. So that's step number one. I move in this direction of components.
But wouldn't your subscriptions and your email be interacting with each other?
Possibly. Possibly. So yes, they would be interacting, but they wouldn't be circular dependent. You have to have dependencies, because if you don't have one library is not dependent, if a library is not dependent on anything, then it can't talk to it. So there's dependencies here. I just have them one directional. They always go in the same direction, top to bottom. I don't have a dependency going the other direction. So yes, they are dependent on each other. They're just not circularly dependent. Subscriptions are not dependent on emails, and emails are not dependent on subscriptions. So I spent 10 months running an engineering group for Living Social in Boulder, and I was in charge of user acquisition. So tip of the spear, collect all the emails. Everybody that knows about Living Social, that was our business, collecting emails pretty much. We at one point tried to break out a subscription service, I think 4 or 5 times, and just couldn't do it because it was so tangled to everything else that we literally just couldn't get the code to come loose. And it was because of all this circular dependency mess.
But what's the difference with having multiple modules under the application?
Mm-hmm.
Like I'm coming from functional programming background.
Cool.
So what's the difference? I don't see it. Like I write simple small modules instead of having one big application.
And that's what this evolution, this step is multiple small modules that live outside of an application.
Yeah, but that's not something new.
Exactly. This is
For me, it's
none of this is revolutionary. But you talk to a Rails developer, and you'd think they just like found that the Earth revolved around the sun. So a lot of this is not new.
yeah.
But what we're struggling with is a lot of people see this as new. Yeah, I mean these ideas have been around forever.
Now we got to know microservices.
Microservices are simply, in my mind, free-running microservices are a deployment implementation detail. But they are, in order to do them well, I have to have this structure. In a functional language, what language are you writing?
Scala.
Yeah, so Scala, you would do this in Scala. Haskell, you would have this in Haskell. Because in functional programming, especially in Haskell, you have your functions. So I'm already forced to move this direction. So yeah, none of this is new. So if you're expecting like earth-shattering new stuff, the rest of this is you're going to be like, yep, we've been doing that for years. This is just simply my attempt to remind people that this is not new and we should be doing it this way because we haven't been. This is why monoliths take 24 hours to deploy, why they take 6 hours to deploy. Why you can't break out a user object or a user service because we've created a mess in our software. Databases, this one gets tricky, and this is where the hand waving starts. I don't have a good answer for this. Does the application manage my database? Do the components manage my database? For those of you playing the drinking game at home, you can take one drink, it depends. The one rule that I do stick to is migrations can only touch one table. Why is that a hard and fast rule? Not exactly.
So you don't spell outside your domain.
Excuse me?
So that you don't spell outside your domain.
So I don't spell outside my domain. Just kind of. At some point I'm going to break this thing up. If I have a file that touches two tables, and one table goes into one microservice, and the other table goes into the other microservice, now I have to touch the file. Now I don't have clean separation. But I always know that a database table will live only in one component. So I make the rule that they can only touch one component, one database table. You can touch multiple, it's just going to be pain and suffering when you try to figure out like, oh, that 12th migration, I got to like now change the file. This just makes it a lot easier. I'm leaning more towards them being in the components, and I'm going to show you why in I think one or two more steps. One more step. Okay. So step 3, break out components. I wanted space, and I wanted harder boundaries between my dependencies. Those were my goals. So now I have room for multiple teams. More room. I had room for multiple teams before, but this just gives you a little more space. This is a really cool one. I now have a strict boundary between my framework code and my domain. In that app, if I wanted to scrap Spring, how much work would it be? I don't have to change the application directory. If I've done my job right. There's probably some repository code scattered down in those components, but I've separated my domain from a delivery mechanism. This is what Rails doesn't do well, unfortunately. Is we went through the like fat models, skinny controllers, skinny models, fat controllers. We don't necessarily do a good job of splitting our domain from our applications all of the time. This creates that boundary. And that's the key to microservices extraction. And I'll show you why in the next step. I'm moving closer to microservices. I have internal APIs that I'm dependent upon. But I don't have the overhead of multiple processes. So this is the cost that people tend to forget about. And why Cloud Foundry is so cool is I've got a cost for running microservices. I have to run multiple processes. I have to monitor those things. I can also stop here. And again, just iterate on my APIs and get some benefits, make some wins, make the company some more money so you don't go out of business. You don't have to take a Series A or Series B or Series C without doing a bunch of engineering. Okay, so promoting your first microservice. When? is a good question. So this is the black art of microservices. When do I break out of microservices? And why do I break out of microservice? Anybody heard of Sam Newman? Works at ThoughtWorks, has a really great book on calling it Building Microservices. There's a beehive on the front. I think he lists, I think it's 12 reasons why you break out of microservice. So this is where it gets to be, it depends. Do I need scalability? Do I need more room for teams? Do I have, do I want to deploy faster? So some reasons why you would, I want to scale a certain bounded context. So if my payment bounded context gets really hot, and I want to scale that higher than my user service, I can do that with microservices. And that's one of the reasons I break out of microservice. This one is controversial, that multiple applications want to interact with a bounded context. Reuse, according to Sam, is not super high on the list of reasons to break out of microservice. Why not? If I have multiple clients and I want to evolve the producer of those clients, how much communication do I have to have? I got to talk to multiple teams. So there's a little bit of friction there the more reuse I get. There's a great talk from an ex-Netflix engineer that he talks about binary sharing. The sharing idea gets a little tricky with microservices, but you can do it. This is a valid reason to break out of microservice. As I said, I think Sam covers 12 of them in his book. I highly recommend the book. I do not get a kickback on every copy he sells. So you have made the decision to break out of microservice. I am now going to show you how easy that is if you follow this pattern. Let me set this down.
Can we see that?
Can we see that? Okay, cool. So we're going to go file by file diffs. Ignore that one. Okay, so I've decided to break out a microservice. What is the first thing I do for my new microservice? I write a README. I create a new application. So I'm going to take that billing bounded context, I'm going to take it, and I'm going to put it in a new application. So instead of the main user management service referencing that, I'm now going to create a new application. With my new application, I have a new build.gradle. Here is my Java application. So I've got a new free running process that I'm going to deal with. There's my controller. So I'm now starting to expose an existing API via HTTP as opposed to in-process calls. That's all I'm doing here, is creating a thicker boundary between that bounded context and the person that calls it. Here's my YAML file. You'll notice that the user management system now loses a dependency. It no longer builds that jar file. But now it gains a client. So now I have another process. I have an endpoint that I have to deal with. I have a client to communicate that. So I've now created this big chasm that I have to jump across to call that thing. I auto-wire the billing client. So instead of now having this charge user use case, I now have a client that's going to do that for me. So now I'm going to call it. But I didn't really change a whole lot. The API stays the same pretty much. I get a user ID and an amount, and here I got a user ID and an amount. I'm just shifting the mechanism by which I call that thing. And then I have to do a bunch of shuffling in here. But you'll notice in the billing client, the one that I broke out, there was a very small change. The rest of that didn't change. So that's it. That's all. If you follow this approach, you're literally just putting those jar files into new applications. If you're a Rails developer, engines. So we have a friend of ours, our office director in Berlin, is writing a book called Component-Based Rails Applications, where he follows this exact same pattern in Rails using engines. That's all you're doing, is putting an HTTP layer around that component with little tweaks. Unfortunately, that doesn't come for free. I now have to know how to contact the billing service. So I now have an endpoint that I have to call. And I have a network communication problem. So when you're doing distributed systems, congratulations, you now have a distributed system. You no longer have the CAP theorem, you have the CA theorem. Why do I no longer have P? Why can I no longer choose P?
Because it will partition.
Because the network will fail. You have to plan for that in a distributed system. The network will fail. So now I get C, I can choose C or A. I don't get to choose P and I have to deal with P. This is the cost. This is real. This is a real cost. This is not inexpensive. I also have a new free running process that I have to monitor. So welcome to the DevOps world. So in order to solve problem number 1, which is I have a free running application that lives on a network, I need to implement a pattern called service discovery. I now want a layer of abstraction between myself and that endpoint. Why do I want that? Why do I want that layer of abstraction?
If it goes down.
If it goes down, that's the next pattern.
Scale.
To scale. So if I have 12 instances of this, I don't want to have to change that app with 12 API endpoints. There are ways to deal with that. I can use DNS and whatnot. But I need that layer of abstraction now. I have an abstraction cost between services. Service discovery is the pattern we use to do that. So let's see what that's going to cost us. Okay, so in my billing application, I now have a new dependency. I am now using Netflix open source. Thank you, Netflix, for providing this stuff for us. I have an endpoint here, which is a health monitoring endpoint. I now also have this library called Eureka, which is the Netflix library they use for service discovery. In my application, I now enable a discovery client, so I now have something else in my app that's going to deal with this like phone book problem for me. That's all I have right now. I just have a phone book problem. I just need to know where to call that thing out. These subtle changes are having to do with the Eureka client. They're an implementation detail, so I have some changes that I need to make for my calls. And I now need to give the new microservice a name, and I need to tell it where the Eureka server is. So I have a third free running process now. I'm running 3 apps in production, possibly multiple instances of those. And then in my user management service, I again enable the discovery client. This Feign client, Feign is a library from Netflix to allow me to declaratively create HTTP clients. I will show you that. So you'll notice here, I no longer need to hard code the billing endpoint. I now ask somebody for that information, and I get rid of the billing client, and I trade that for more Eureka configuration. And here's my Feign client. So if you've seen Spring repositories, this will look really familiar to you. I implement an interface, I tell it's a Feign client. They did this because they don't want you implementing logic in your API clients. Why should I implement logic in my API clients, my microservices clients? Why is that a bad idea? What was that?
You don't control all of them.
I don't control all of them. I also don't want to put logic in there. Because if I'm running multiple consumers in multiple languages, I have to write multiple API clients, and I have to make sure that logic is duplicated. So this incents me to push all that logic down into the microservice, and this is simply a dumb HTTP call that returns me a Java object. So it's super simple HTTP back and forth. And then, of course, I have another application. I have my README. And then I have my build.gradle to build it up. Here's my app. The magic of Spring Boot Cloud, or Spring Cloud Boot. And then here's some configuration. So I had a problem, I had a dependency that I wanted to loosen. In order to loosen that dependency, I decided to pull in a new application. So there are multiple ways to do service discovery. One of them is this route. I have a third-party zookeeper-like thing that manages that for me. You can do it with DNS. You can do service discovery with DNS. The downside of using DNS for service discovery is time to live problems. I have to set my TTLs really low in order to get the automatic scaling discoverability, and now I've got a network congestion problem. So there are many ways to do this. This is the one that Netflix chose, and we decided to use that. So in order to reduce coupling, I added another application. So that's great. I've reduced my coupling, so I can scale them independently of one another. But now I have increased complexity of another application, and I trade that for scaling. So this is where it depends. Is the cost of running another application in my infrastructure greater or less than the benefit I get from flexibility? So the one sales pitch I will give you if you're running Cloud Foundry, this is negligible, and this is a benefit. So it doesn't matter what this one is. If you're running on legacy infrastructure where it takes 6 months to get a server for this application, now that cost is gigantic. It's almost impossible to do. So again, it depends. You have to weigh these costs and pros and cons. It's all a cost-benefit analysis. It's engineering. Okay, so back to your problem about the network failing. We have another pattern called the circuit breaker. So everybody's familiar with circuit breakers? Sweet. Kind of.
Yeah.
You turn them on, you turn them off, the electricity goes on and off. Make sure you don't fry yourself when you go to fix a light bulb. So I told you that you lost the ability to choose partition tolerance. That will happen. That will happen at the worst time ever when you're selling millions of things. So why do we need partition tolerance? Why do we need a circuit breaker? To make sure my users don't see hey, your service just went down, your network just failed. It creates these bulkheads. Everybody familiar with the reason that ships have bulkheads? So when one part of the ship leaks, you can lock that off and keep going. This is the same deal. When that service fails, because it will, you want to isolate that service from the rest of the application because you now have a distributed system and you have these dependencies you have to deal with. You want to stop the domino problem. So let's check that out. So, anyone want to guess what the pattern of this looks like? Anyone want to guess, what do I add in this situation?
A Netflix dependency.
I had a Netflix dependency. I had a fourth free-running process that I have to manage. So I enable circuit breaker. I auto-wire the client. There's a bunch of code in here that I'm going to blow through. If you want to look at it later, awesome. I get this thing called Hystrix, which is the circuit breaker pattern. What I get the ability to do now, for the functional programmers in the room, I now have a maybe monad. I now say, hey, this is what happens when things go well, and here's what happens when things don't. It makes it very obvious to me what my success condition is and what my failure condition is. So that when this call fails, this method gets called. So the most notorious implementation of this is the Netflix recommendation service. That thing supposedly goes down all the time because it's super complicated. You ever gone to Netflix and you gotten hey, we couldn't get your suggestions, but here's a canned list of suggestions. This is where you return the canned list of suggestions. And as soon as this fails, everybody upstream doesn't really know that that service failed. It forces you to think about that. I now have visibility into error states because the network is going to fail. Now,
Is it good to have that? Is that in the microservice or is it in the client?
this is in the billing microservice, which is calling bill user. So this is in, I think it's the microservice. Yeah, it's in the microservice. Yes, because I have multiple microservices now. So again, it's super small changes. Some of these changes are, like the big change here is, at one point in Hystrix, I could not annotate Feign clients with a fallback. So I had to implement this service layer to get around the fact that I couldn't tell Feign that when this interface method fails, call this other one. They've since fixed that, I believe, but that's why this is a big addition.
So does that solve the network going down problem?
It doesn't solve the network going down problem. What it does is prevents me from caring that the network has gone down. I still have a problem. I still need to look at that, but all my users don't see that my network is falling apart. I get this canned list of responses.
Obviously, though, it depends what part of the network is on there.
Of course, it depends. Thank you. That's 2 drinks if you're playing along at home. Yeah, I mean, everything depends. Like if the whole network goes sideways.
I mean, if your discovery service goes out.
Yes, if your discovery service goes out. You can run multiples. The other place this is nice is not for partition tolerance, but for service slowdown. So if this service starts to get slow, the circuit breaker will trip, so you don't just crush the thing into the ground. It'll actually give this thing room to breathe, and if you're doing microservices properly, you're monitoring that thing, and the big red light's going off in your ops center, and people are feverishly working to get that thing back healthy. But if you keep crushing it with requests, it'll never get healthy again. So there's some throttling that goes on here, but you don't even see it. It's all wrapped up in the patterns. So anybody that's familiar with any other pattern-based things in software, these are simply distributed services patterns. This is what I love about Spring Cloud, is it lets me wrap this up if you like annotations in Java. There are other libraries that do this for many other languages. So it's just nice to have those patterns built in. Because as an app developer, I don't want to have to reinvent this wheel. This is not something I'm good at. I don't have a computer science degree. I want somebody else to figure that out. I just want to make sure, my app works.
But that's all what it takes to get
That's it.
circuit breaker, like enable circuit breaker.
That's it. This is all it takes to implement Hystrix using Spring Cloud and Spring Boot in Java. Yeah, it's pretty cool. So that's my one sales pitch for Spring in Java. I also had this example in Kotlin. If you're a Kotlin fan, I also did it there too. So you have some shifting around in here of services for clients because of that Hystrix limitation. And then here's my other app. The other cool thing about Spring Boot is if you look at these Hystrix servers, it's like what, 15 lines of code, and most of that's Java boilerplate. So to get a fully running Hystrix dashboard with all of the magic, I run this, plus some dependencies on RabbitMQ. So again, we want to wrap this stuff up and make it easy to use. So I've now solved that problem. So I now have decreased the risk that a flaky service will cause the world to crumble around me. But, like the common theme, I've got another app to manage. But I've increased the resiliency. I've also increased the visibility. So the one thing I don't show you here is Hystrix has a pretty dashboard. So if you're doing microservices right, you have dashboards all over your ops center or in your development area. You can actually look and see what services are healthy. It will tell you what circuits are open and what circuits are closed. Okay, so that's the end of it. The nice thing now is you've paid all the upfront costs. If I want a third microservice, what do I have to do? I create a new app. I extract my component, I wrap it in the app, and I deploy to production. I don't need more infrastructure, because I've already got I paid the infrastructure cost at the first microservice. The second one is easier, the third one's easier than that. By the time you get to 12, you've got all kinds of other problems, but not necessarily the same ones. You can change up the communication interface. So if I want to go to message queues, what is the one piece of software? One piece I have to change to go to a message queue? Just the application. The domain doesn't care how it gets its messages. Just the application changes. Part of Spring Cloud is a distributed configuration manager. So if you want to run another app in production, When you're running huge series of microservices and you want to change configuration on one set of those microservices, you don't want to have to push apps. There isn't a way to do distributed configuration that uses a Git repository and things like that. So you can ramp up the complexity if you want here, if you know you're feeling lucky. Or you just don't do anything. You just run this thing, and you run it, and you run it, and you run it, and you make more money, and hopefully you don't, hopefully your startup doesn't fail. And if your startup does fail, you haven't wasted money on all this infrastructure up front. You've wasted money proving out your business model was wrong, and technology's not going to save you from that problem. The greatest part is you get to choose. This is not a consultant coming in and say, thou must build microservices. As an engineering team, if you're at step 2, you have a good, honest discussion of when we want to go to step 3, or when we want to go to step 4. Or we don't ever go to breaking on a microservice because we don't have the platform for it. We just don't have the infrastructure. We can wait to do that. And while we're doing that, we can build up our ops team, and then we can go to 4. Because those are all costs. You get to amortize those costs over a longer period of time. Oh, I always forget to do that. So some resources. Slides are here. Code is here. If you want the Kotlin one, tweet at me. I need to add the Kotlin version in here. This is the blog post where those 2 pictures of Rails versus Spring come in. A little bit of a musing of mine on that. The App Continuum stuff from Baranek. Steve Brown video, or Simon Brown video. Highly recommend you watch that. If you're interested in Spring Cloud, if you're a Java developer, you're already using Spring, highly recommend checking this stuff out. And then Martin Fowler tends to be my go-to person on microservices, as does Sam Newman. I need to add a link to his blog in here too. Just trying to figure out what people are talking about. But always with that eye of, oh, does this always apply? Or what happens? And I find that Martin Fowler tends to be really good at that. Like, oh, maybe. Here's why, here's the pros and the cons. You can make your own decision. Any questions? Yes?
So, you mentioned Martin Fowler a lot, which is a good thing, I think. Have you tried to get any of this into a template similar to what he did for the refactoring patterns?
No.
That would be interesting.
That's an interesting way to look at it. This talk, I gave this talk for the first time last November in Stockholm, and I've been a little lazy on kind of just trying to push it forward. I think part of it is I just want to get it in front of people. I'm waiting for that one talk I give where everybody's like, you're completely wrong, and then I'm delaying the architecture decision. But to your point, none of this is revolutionary. So I don't know if I'm ready to codify it yet because it feels just like it'll solidify. But yeah, it's a good idea at some point maybe. Or maybe somebody else will do it. I'll just give it enough times and somebody else will do it for me. Anybody else? Cool. Well, I'll hang out for a little bit. If you have questions, want to come talk one-on-one. If not, thank you so much for your attention and have a good rest of your evening.